All right, let's go ahead and determine the logical equivalence of conditional statements. So first off, a conditional statement, remember, is an if-then statement. So when we're looking at some statements here, P to Q. So if P, then Q is a conditional. Now, when we're talking about equivalence of conditional statements, we are talking about contrapositives, which are equivalent to the original. Now, I'm going to go out on a limb and say if P, then Q, which is our first piece here, I'm going to say that is equivalent to the conditional statement not Q, if not Q, then not P. So I'm saying these two statements are equivalent, these two conditionals, which we then would call them contrapositives. So let's use a truth table to talk through this. So first things first, we have two statements, right? P and Q. So because there are two, 2 to the second power is 4. We have 4 lines in our truth table. So P would start out with true, true, false, false. Remember the first one we split in half. The first half is truth. The second half is falses. And then the second one, so in this case Q, we would alternate true, false, true, false. Now let's go ahead, because we are also going to talk about not Q and not P. Let's go ahead and talk about the truth table columns here for our negations. So not P would flip them around, so be false, false, true, true. And then not Q would be, again, flipping them to the opposite, so false, true, false, true. Now, when we are in truth tables for conditional statements, remember that the if-then statement is true for all combinations except true, false. So when I'm looking at P, if P, then Q, I'm looking at these two statements. So first things first, true, true gives me true. The second row is true, false, which we know for a conditional gives us a false. The rest of them, false, true is going to be true, and false, false is true. Now, when I go to if not Q, then not P, I'm dealing with my negations. And Q comes first, so not Q. So I'm looking at false, then true. So false, false gives a, false, false is true. If you look at the next one, we go to true, false. In a conditional, true, false is false. False, true is true. True, true is true. Now look at these two columns. True, false, true, true. They are equivalent. So if P, then Q is an equivalent statement to if not Q, then not P. Now that's using symbols. Let's go ahead and talk about words. We're going to write an equivalent statement to the following. If you are Cindy's sister, then you have blue eyes. Okay, so this is an if-then. If P, then Q. So remember, our conditional is if not Q, then not P. So if we go ahead and type it, okay, so not Q. So if you don't, right, we're negating, don't have blue eyes. Oops, I forgot the word eyes. If you don't have blue eyes, then you are not Cindy's sister. Because remember, it's not P. If not Q, then not P. So if you don't have blue eyes, then you are not Cindy's sister. So you got to keep that whole not, the negation people's in there. So in words you can read, if you do not have blue eyes, then you are not Cindy's sister. And that is determining logical equivalence of conditional statements, thinking both in symbols with the truth table and also in English statements. Thanks all.